Tonight's video here is going to review the first part of data in detail for those of you that need assistance with this. And so we're going to focus on complex charts for this video. Now when we talk about a complex chart, what we're talking about is we're talking about a chart that's got multiple columns, multiple rows, maybe multiple pieces of data for each category. And so in this example that I have here, we're going to use this to go through some strategies to help you with answering the questions for the ACT and the plan. And so the first thing that I always do when I look at a table like this is I always look at the heading of the table and identify what that table is talking about. So in this case here, our table is table 3.4 and it's freezing point of various solutions. So from this information, I'm going to get the freezing point of different solutions. If there's questions asking me about freezing points, this is the table I'm going to go back to. Now, the next thing I always look at here is the column headings themselves. And so we've got a couple of different column headings. One is that we have temperature degrees Celsius. So what this is saying is it's saying that for each of the pieces of data, the temperature is going to be given in degrees Celsius. The second portion of data is going to be second portion of data here is going to focus on the concentrations of the solution themselves. Okay, so when it talks about concentration like this, we're dealing with sodium chloride, ethylene glycol, glucose, calcium chloride. So the question you have to ask yourself is, what is the percentage? What's this being diluted with? Now, normal procedure for this is it's diluted with distilled water, so it shouldn't affect it. The 0% column there, that is going to be our control for this. So really we shouldn't see anything happen in the 0% column. Okay. After that, we'll start seeing some changes as they add more of the solute itself. So in this case, that's sodium chloride, ethylene glycol, glucose, or calcium chloride. Now, after I have identified what my different concentrations are going to be, we need to look at the rows themselves and see what is it that they're exactly testing. So we know that they're looking at solute concentration, and so in this case, they gave us 4 different solutes that they're testing. One of them sodium chloride, one's ethylene glycol, one's glucose, and one's calcium chloride. Now once I know what the table itself is talking about, then I can start looking at trends. So if we look at the trends for each row here, what we see here is that for sodium chloride here, as the concentration increases, the freezing point at which the solution freezes is getting lower. So the temperature's having to go lower and lower as more sodium chloride's added. If we look at the second sample, the ethylene glycol, we see a similar pattern here. The temperature is going to decrease as it gets lower and lower. Our third sample, glucose, we see a similar trend. The more glucose, the lower the temperature. Until we get to calcium chloride, in which we also see the same trend. The more calcium chloride, the lower the temperature is at which it freezes. So after we've identified any trends going on in the rows, we're also going to look at the columns themselves. And if you look at the column for 0 degrees Celsius, we see that that's consistent. All right? There's nothing being added except for distilled water. So that's the temperature at which water freezes. Now if we look at 1%, we really don't see any noticeable trends. It's lower than the 0 degree or the 0% samples. The 5% samples are a little bit lower than their previous counterparts, but there's no trend for the columns themselves. And if we look at 10%, 20%, 25%, we also do not see any noticeable trends for the column. The last thing I'm going to look at here is I'm going to look and see, are there any overall trends that I could identify for this chart? And so looking at this, what I can see is that calcium chloride is going to lower the freezing point the most for these samples, and that regardless of the solute itself, whether it's sodium chloride, ethylene glycol, glucose, or calcium chloride, increasing the concentration of any of those decreases the temperature at which the solution freezes. So those are the overall trends that I observe in this chart. Now, as a review of the steps I go through when looking at a complex chart like this. First thing I ask is, what do the headings mean? So what is being displayed in that chart? Second question, what does each column display? Figure that out. Third question, what are the rows displaying? Fourth question, what are the trends for each row? Okay, most charts tend to have trends on the ACT or plan test, either going based on the rows or the columns, so see if there's a trend, if there's a pattern present. Fifth, what are the trends for each column? And lastly, what are the overall trends for the graph? Now, if you take the time to do this quickly before going into the questions, then you have an idea of what to look for when answering the multiple choice questions. This shouldn't take you very long, but look at the chart, see what information is being presented, and then go and focus on the questions themselves. You can't successfully answer the questions if you don't know what the charts, graphs, and tables are asking of you. So this is the first part of data in detail focused on complex charts. There will be more to come.